So I open this and then just rename or change the keyword from setnum to AirSet. Okay, so that's very simple, right? So yeah, I'm going to delete this one, and then let's go back to the user interface. Okay, so after we have the AirSet grid, let's go back to the master data. Yeah, so let's be careful a little bit. So actually everything will be simple. Run spec, title, metric, here everything. No particular keyword, but let's be slower here. Grid, okay. So let's open the grid and then include. Of course, we will include the grid. Grid include, and then AirSet. Okay, AirSet dot include. Okay, so we generate the AirSet grid, and then of course we need to input that in the grid section. And then let's use the keyword arithmetic. And then for permeability in X direction, of course the keyword is perm X. And then use this one. If AirSet double equal 1, which means the AirSet is 1 here. Okay, or maybe we can go to the AirSet here. So the AirSet will be like this. So 1 blue, and then 2 is this, I think it's teal color, TEAL, and then the third one is green, and lastly red. Okay, so we have AirSet double equal 1, then permeability in X direction can be calculated using this formula. For example, we have this correlation 12 multiplied by the exponential of 5 multiplied by the porosity. So basically we need to have grid porosity in this case. Okay, so this case assumes we already have another grid that contains the porosity distribution. Okay, and then else if not 1, what about region 2? And if it is 2, then use this formula. If not 1 and 2, maybe 3, AirSet double equal 3, then use this formula for the third region. And if not, it means it is the fourth region, and so we use else this formula. Okay, so if blah blah blah, then use the law or the rule, and then don't forget to use this. Be careful, it's different from this slash. It's reversed. Okay, and then else if, then, and then use this slash again. Else if, then use this reverse again. Else if, then use this reverse again. And close with and if. And don't forget, we have another, this usual slash that we normally use here to close the arithmetic operation. And after that, yeah, we can copy the permeability in X direction to be exactly the same with permeability in Y direction, like the one we do normally, usually, and permeability in Z direction, we can use this formula, this arithmetic formula, perm X multiplied by 10%, for example, and then close with this one. And that will conclude our learning today. So the main thing is that we create array grid using the available information. And in this case, the available information that I need, that I use to create my array grid is the saturation number grid. And then use arithmetic, okay, operation to generate my perm X. And to generate the perm X, because perm X should be 3-dimensional, I use AirSet because AirSet also 3-dimensional. Okay, I use AirSet grid and then use this correlation. This correlation is from another source, maybe from your petrophysicist, from your friend geologist, and then use this like this one. So maybe you ask about the poro. Okay, let's find it. Where the poros? See, I think it's in grid. So let's open include grid. Okay, it takes a while. Yeah. And then yeah, we have Newton, coordinate, no eco, egnum, and yeah, we must have porosity, but in this particular case, I'm not sure where it is. Oh, yeah, here. So we have actually the grid for the porosity, and we use array set grid, and then we have porosity grid to calculate or to generate our permeability grid in X direction, Y direction, and Z direction. Right, so I think that's all. So everything after this is normal, except if you want to extend the learning to include this other arithmetic operations, but I think it's a topic for another day. Okay, so I think we can close. Thank you so much for watching. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator Eng-Man videos. Thank you.